Welcome, hello, good afternoon to today's Tuesday, the 11th of March 2025's lunchtime lecture, which is nominally titled Can Regenerative Agriculture Work, or Regen Ag in Potatoes. So I will do a very brief skim read of Jane's preamble and then introduce to Jane and leave it with Professor Jane Rickson on the PotatoLITE project. Current potato tillage operations can lead to a loss of soil health and increase in carbon emissions into the atmosphere. I think it's a no-brainer that growing potatoes historically takes a lot of horsepower to beat soil into shape. And really, that is what Jane is going to speak to us about today. There's a very long profile of her eminent professional career, which I'm not going to read out. And if she wants to brag, she can deal with it later. But it's also on the website. So I'm going to hand you over to Professor Jane Rickson, who's going to talk about the PotatoLITE project. And if you go slowly, I can write notes and write an article about this later. Thank you, Jane.
Very good. Thank you, Mr. Newbold. Good afternoon, everybody. Lovely to be here. Thank you very much for joining this lunchtime seminar. I am just a spokesperson really for this amazing project that I want to introduce to you all. Apologies for those of you that already know about the project. So it's all about PotatoLITE, enabling regenerative agriculture and potato cultivations. Yes, so those of you that don't know me, Jane Rickson, and I'm delighted to be here. And I'm a spokesperson for this very exciting new project, PotatoLITE, enabling regenerative agriculture and potato cultivations. You can see there that it is a project that has many different partners. It's a large consortium. And the project as a whole is co-funded by Defra's Farming Innovation Programme, and it's delivered through Innovate UK. And the project lead is PepsiCo, who you will all know are producers of Walker's Crisps. Some of you may even be eating Walker's Crisps for your lunch as we speak, which would be very appropriate. That would be good. Or maybe some of you are having McCain's chips for your lunch, which again would be very appropriate because McCain's are also a project partner. What I really like about this project is that it is a true partnership between industrial partners, PepsiCo, GRIMME, McCain, and so on, farmers who are involved in the experimental trials that we're running, and also academics. So I'm delighted to see Dick is with us. I don't know if other colleagues from Harper Adams are here as well, but again, collaboration between Harper Adams and Cranfield as the academic partners on this particular project. So it is a cross-industry partnership to validate new approaches to potato cultivation. And as Andy said in the introduction, we all know that potato cultivation is incredibly intense and can do damage to soil. I'll say a little bit more about that. But first, I'd like to share with you the video for the project, which is all very corporate and very professional. So just to give you a flavour of the project before I come into more detail, I'd just like to play this video. Hopefully it will play. Bear with me. Sarah, let me know if this doesn't work okay. Thank you.
Perfect crisps, chips and fries come from great potatoes. Produce high-yielding quality potatoes in conventional cropping systems around the globe. The soil is cultivated to create a deep and uniform seedbed, free from stones and clods, to provide a favourable environment for potato growth. This can require up to 6 passes of machinery, moving up to 6,500 tonnes of soil and stone, and using over 100 litres of fuel per hectare. The intensity and frequency of these potato tillage operations is perceived as challenging with the current drive towards regenerative agriculture and net zero. Whilst reduced tillage technologies have enabled regenerative agriculture in cereal crops, these systems have not been developed for the production of potatoes and other root crops. PotatoLITE aims to solve this by developing regenerative practices that can be used across the potato industry. The project has 4 main objectives: develop and validate novel, lower intensity tillage solutions, assess the impact of these cultivation strategies on soil health and greenhouse gas emissions, deliver practical solutions to future-proof potato production within sustainable farming systems, and provide consumers with more sustainable food choices. We are developing 3 new systems with different levels of soil tillage intensity to compare and benchmark these to conventional cultivation practices. We are measuring more than 20 different soil parameters across all systems to assess soil health and monitor resilience in the following seasons. These new practices will be made available to all UK potato growers, so we can spread sustainable practices throughout the industry. PotatoLITE
Okay, so that gives you hopefully an overview of what the project is all about. Obviously, that is a corporate video that's made up to describe what the project is about. And I'd like to go into a little bit more detail now as to the various components of the project. So as the video showed, the intensity and frequency of potato cultivation operations do not fit with the current drive towards regenerative agriculture and net zero. And that has been demonstrated by several academic publications, and just that is known by the industry. To produce the conventional seed beds that you need for potato production, you need multiple, deep and energy intensive cultivations, which just because of the pure disturbance of the soil is going to expose any soil organic carbon in the soil to the atmosphere. The carbon mixes with oxygen, so we get CO2 emissions coming from the soil. And the sheer number of operations where that soil is going through the machine means that that carbon is being exposed to the atmosphere, let alone the damage that is being done to the soil health, all the other parameters such as aggregate stability, bulk density, and so on and so forth. So if you just unpack all the different operations involved in planting potatoes, you'll see that we've got things like bed forming, we've got bed tilling, we've got de-stoning on stony soils, and then we've got planting. And again, I'll say a little bit more about how we quantify the impact of those different operations required in conventional potato production. I'll say a little bit more about how we quantify the damage that could be done to soil health. We certainly know that tillage can affect soil health, and it is a significant driver of greenhouse gas emissions. So what the PotatoLITE project aims to do is to deliver these novel, sustainable cultivation approaches that will enable the adoption of regenerative agriculture in potato production. I often get asked, what do you mean by regenerative agriculture? And it's probably as many definitions as you've had hot dinners. And certainly it's like sustainability. How do we define that? The way I like to look at regenerative agriculture, it's to do with actually building back better. It's not about conserving what we have. Particularly as a soil scientist, I'm interested in soil health. And the old paradigm used to be it's about soil conservation. Let's conserve what we've got. And I think regenerative agriculture goes one step further. And not only does it conserve what we have and protect what we have, such as organic matter, organic carbon, but it actually tries to build back better. I know that term has been misused, no comment, but I do think it's this concept that not only are we trying to conserve and protect, but we're actually trying to do better. We're trying to get to a better level to build back even better soil health, for example. So, and again, I'm very biased, by the way, in this presentation that it's mostly about the soils. And we have a bit of a joke in the consortium that, you know, people are talking about the yield and the canopy cover. And I said, yeah, but it's all about soils ultimately. So what is PotatoLITE trying to do? It's trying to develop these novel, lower intensity cultivation solutions that will help towards climate change resilient supply chain. And again, a lot of our industrial partners are really looking forward to how they can make their supply chain more resilient in the face of extreme weather events and climate change. We want to try and quantify and benchmark the impact of these different cultivation strategies on soil health, which those of you that know me, I'm always banging on about the importance of soil health. But also in terms of lowering greenhouse gas emissions. And because we've got farmers involved, and I'll say a little bit more about the farmers, the producers who are key to this project, we want these strategies to be practical and grower approved, not just blooming academics making some technical solution. We actually are working with farmers and they will tell us that's just not feasible. We wouldn't do that. And that helps us to moderate what these solutions are going to be. It's not just academics thinking up theoretical, hypotheses of what might happen. We've got to convince the farmers to take these strategies on board. And so, as I say, we're trying to link in with policy change. In particular, if you look at Defra's old now 25-year plan, which sort of drove a lot of agricultural and environmental policy, there is a lot in that about soil management, trying to reduce greenhouse gas emissions and the role of agriculture in meeting net zero targets. And then finally, and again, this is very much to do with the corporate world, to respond to consumer demand for more sustainable food choices. And I'm not going to open up that can of worms in terms of whether it's the supermarkets that are driving this demand for sustainable food and food security, or whether it's the suppliers or whether it's the consumers. That is a whole different lunchtime discussion as to where the drive for sustainability and food security comes from. But anyway, that gives you a feel for PotatoLITE is directed to the industry, to policy and to consumers as well. All right, well, again, I'm not going to sit in my lab at Cranfield and do this project. We have to go out there in the field and be realistic about carrying out these experimental trials, looking at these novel cultivation methods. We are delighted to have 4 growers on board, 2 over in the west that are sort of managed by Harper Adams, and then the Cranfield sites are based up in Bridlington, near Bridlington, where we've got Suttons, and then in Leicestershire and Nottinghamshire, we've got a slight change this year for Strawsons. And these are significantly large producers and growers of potatoes that contribute to the supply chain for PepsiCo for crisps and for McCain's for their oven chips and other potato products. The trials are running from 2023. That was our first year, although we did have a pre-year before that, a sort of pilot trial to make sure that this was going to work in reality. And we've got 3 seasons data that we're collecting, 2023, 24 last year, and then 25 this year. Those trials are continuing this year. And what are those novel cultivation strategies? So this is a very simple schematic of what we're trying to do here in this project. We have 4 treatments. The first is a conventional treatment, which follows what many of our growers are actually doing in terms of producing their crop of potatoes. And as you can see, just by the list of operations that is necessary to produce a field of spuds, we need often, not always, by the way, not all of these operations are needed everywhere, but I'm just saying worst case scenario, you could be looking at 6 different field operations. You might need primary cultivation. That might be dependent on what was growing last year and how tight the soil is, followed by a secondary cultivation, followed by a bed forming device. You need to till those beds. You need to then de-stone if the stone's content is very high. And then finally, you need to plant your spuds. So you can imagine the number of operations involved where you are disturbing soil, you're exposing that soil carbon to the atmosphere, plus damaging the physical structure of the soil and so on, let alone the biological implications for earthworms and other biological indicators of soil health. And then the project partners came up with 3 what I would call sort of novel cultivation strategies where we are trying to ease off the gas a little bit, literally ease off the gas, just reducing the intensity and frequency of those operations in the field. So we had a rotary tillage operation, and you'll see there why GRIMME are involved in this project, because GRIMME have been developing kit that try to combine those different operations all in one pass. So this is very novel. This is where the novelty comes in and the mechanisation comes in to get a bit of kit that can do all of those operations. So, so we have that GRIMME piece of kit. We're comparing the rotary tillage then with a low disturbance tine, again, trying to take the gas off the intensity with which we're cultivating the soil, we're upsetting the soil, we're disturbing the soil. And then again, another treatment that we have is that we're looking at what effect does a cover crop have? If you go into potatoes with a cover crop having been in place before the potatoes are cultivated, is there any legacy effect of that cover crop in terms of soil health, in terms of soil structure that has been put in by that cover crop so that the subsequent operations are less damaging to soil health? Now, I don't know until this project started, and in fact, we still are gathering the information to know how much legacy effect can be gained from having that cover crop. And the reason that we've designed the experiment in this way, you'll see the bottom two treatments, one has got the cover crop, the second one hasn't got the cover crop. So we can make that comparison as to whether growing a cover crop over the winter until your spuds go in round about March, April time, whether that legacy effect of that cover crop, if you get the species right, you get the root architecture right of that cover crop, can you see that effect causing less damage to the soil when you then put the potatoes in? So that's our idea. And you'll see on the right hand side, we've got the very intense tillage operations associated with conventional practice. And can you ease off the intensity and frequency of those cultivations without having negative impacts on soil health or indeed yield? So ultimately, we know our growers, at the end of the day, they're interested in yield, not only just yield, but marketable yield. How much of those spuds, what proportion of those spuds will go to market? They don't suffer from defects, bruising, and so on and so forth. Now, how do we then measure this intensity of cultivations? And there's a very cool tool that some of you may already know that's come out from the USDA, which is called the STIR rating, which is so brilliant because you are actually stirring the soil. But that's just a coincidence that the acronym is STIR, as in stirring the soil, because it actually stands for Soil Tillage Intensity Rating, STIR. And through those of you that know Philip Wright, he's a wizard at being able to calculate the STIR rating for different cultivations, for different field operations. And again, I'm not going to go into detail there. And those of you that know Philip Wright can speak to Philip about this STIR rating for these different operations. So you'll see there, Philip has calculated the STIR rating for a plough, for a sumo trio, for example, that could be an example for our secondary cultivations, for example, for a bed former, etc., etc. And you'll see there that STIR is calculated depending on the type of cultivation that you're carrying out, whether you're lifting the soil, whether you're compressing it, whether you're mixing it, whether you're inverting it, whether you're fracturing it, which obviously is a function of the implement that is actually being drawn through the soil. It also depends on the operational speed. It depends on the operating depth, big time, because again, I'm really interested in about the volume of soil that is being lifted and disturbed. The proportion of soil disturbed, which is based both on the surface and also underneath at depth. And then you can imagine, if we take all of those things into account, the STIR rating is closely associated with the energy expenditure and the fuel consumption. Because if I'm carrying out those operations at depth, I'm going to require a lot more fuel and energy than if I'm just carrying out those shallow operations. And let's face it, many farmers carry out conservation agriculture, not to control erosion or runoff. It's purely because it needs less fuel if you simply tickle the surface of the soil rather than do inversion ploughing. I'd like to think that people are carrying out conservation tillage because of erosion and runoff control, but I'm also realistic to know it's about fuel consumption and fuel savings. And as I say, there's a little bit of information about how STIR has come about. It's associated with the revised universal soil loss equation that I know Dick Godwin will know and love. and maybe hate, I don't know, but anyway, that's another lunchtime session talking about the universal soil loss equation. But that's where STIR has basically come from. And we know that it is related to the effects on soil health and greenhouse gas emissions. As I hope I've explained, the more you disturb soil, then the negative impacts on soil health and greenhouse gas emissions. All right, so what do these different treatments look like in the field? And obviously we're taking loads and loads of photographs to show what's actually being done in the field, what it actually looks like. I'm only going to report, because I'm just giving an overview of the project here. I'm not going to go into detail, but here are some images that we took from year 1. This is planting at one of the sites that has a very high stone content. It was just awful in terms of trying to take soil samples and so on, because there was just so much stone content. Incredible that the farmers are growing potatoes there, but there we go, that they're limited with the soil resources that they have. So we have our 4 cultivation treatments, and at each of those 4 sites, the 4 growers that we're working with, I am delighted as a soil scientist, a field scientist, to say we have 6 replicates of each of those cultivation treatments, which is brilliant, because the more replicates we have, then that is more robust as a scientific experiment. We have more degrees of freedom, we have better statistical significance, and more reducing the error bars where we have more replicates. So I'm delighted about that experimental layout, that we're not limited to 3 replicates or 1 replicate, as you sometimes see, which you can't do any stats on at all. Okay, so you can see here what the different treatments look like. You can see the effect of the cover crop. On the right-hand side, where we've got the cover crop from the previous winter, you can see we've got lots of residue on the soil surface. And we're hoping that that can reduce the amount of soil damage, adding organic matter to the soil and doing all the good things that we know crop residues and organic matter can do to the soil. Notice also the different depths from those different treatments. So where the maximum depth, no surprise, is from the conventional treatment, which is maximum depth of 35 centimetres of soil that's disturbed. But where we've got those low disturbance tines, then we're only going to a depth of 26 centimetres. So that should be good news from soil health, but can we still grow a decent crop of spuds from only going that deep? And I will reveal later as to whether that's the case. Notice also the number of passes. Again, because we've got this bit of kit that combines those different operations, we don't need to go onto the field so much. And it means that we're saving fuel and we're saving the damage that can be associated with going on the field when it's much too wet. And again, you know, it's so weather dependent what happens to the spuds in terms of planting. We are watching the weather calendar because we're due to go out in the field next month, beginning of next month, and planting. But if the weather is rubbish, then clearly we're not going to be able to go out. So it's very weather dependent. And again, we're interested as to whether these soils are more resilient, that you can go out even when the soil or when it's been raining. Can we extend that workability window by improving soil health with these more conservative operations? Okay, very good. So I'm going to say a little bit about Cranfield, but in terms of what we're doing, what's our role in this? And really, I'm doing that as an excuse, because if you all ask me about the mechanisation side of things, I'm really not the person to answer that, I'll be honest. And I would refer you to my colleagues at GRIMME, who are the mechanisation people. So forgive me for this, but my role in this, and Cranfield's role, and Harper Adams' role in this, is more to do with the okay, so what's the impact of those different treatments on soil health and greenhouse gas emissions? And this is a very busy slide, but shows some of the things that we're actually measuring to answer the question, do you get differences in soil health depending on which of those 4 treatments? So my hypothesis would be the conventional would be awful for soil health because it's damaging and disturbing the soil 6 times over, or however many. But if we can be a little bit less frequent and a little bit less intense, then my hypothesis would be that my soil health would improve compared with the conventional. So how do you know that? What is soil health? Oh my God, that's another lunchtime lecture. But what is soil health? Well, I deliberately dodged that bullet by saying to all project partners, okay, project partners, if you could go on a desert island disc and choose your favorite soil health metrics, that would be a very sad place, I'm sure most of you think. But anyway, I think that would be a lovely desert island to go to. But if you went to a desert island and you could only choose your favorite soil health metrics, what would they be? And we asked everybody in the consortium what their answers would be. And we compiled that to come up with this definitive, dare I say, list of soil health indicators. We measure these at the baseline before the cultivations go in, just to make sure that we've got a level playing field before we put the cultivation treatments in. We then make these measurements post-planting, so after those 4 treatments have gone through. We also look to see whether there is any legacy effect from those cultivations post-harvest. And frankly, any of you that have seen a potato field being harvested, the likelihood that there will be any legacy effects from cultivating to a lesser intensity, I think are unlikely, but nobody's tested that. So we still have to carry out those measurements post-harvest. And then again, we're thinking about long-term impacts. We then go back into the potato field when it is in the next crop, often winter wheat. And again, we hope amongst hope that those legacy effects of the different cultivation treatments will be seen in the follow-on crop, as I say, usually winter wheat. And again, I'm sure most of you would say, don't be daft, of course there won't be, but I would then challenge you to show me the evidence that that is the case. And that's why we're collecting that follow-on crop. Again, those soil scientists amongst you, you will see that we have a whole suite of soil health indicators, chemical indicators, physical indicators, biological indicators. And these, as I say, I'm sure your favorite soil health indicator may not be in that list. And I apologize for that if that's the case, but this list was chosen by the project partners who, as I say, represent everything from industry right through to academics, and even our agri-tech centre people fed into this. What would you need to see change, or what would you need to see different if you were looking at soil health? All right, okay. So I'm going to now share some of the results that we observed, watching my time. Yeah, no, I'm right for time. And again, I think a picture is worth 1,000 words. I have got some words and some numbers later on, but again, I want this to be fairly sort of headline results rather than being very, very academic for this lunchtime seminar. But as I say, the results are in. So in year 1, you will see that we've got our 4 treatments, and there was no significant difference in plant establishment in year 1 for the 4 treatments. But spacing was more variable in some of the treatments, it has to be said. And that often was related to the cover crop getting in the way of the planter. So actually trying to plant through the cover crop could be an issue in places. But overall, plant establishment looked very good. And my agronomy friends, and again, I'm not an agronomist, but my agronomy friends tell me that plant establishment is really important, is a really good indicator of how that crop is going to establish in the future. Okay, so that was what the crop looked like. Again, throughout the season, we also measure canopy cover. And again, we found that in year 1, that if you average the canopy cover across the 4 sites, again, there were no significant differences in treatments. So whether we had the conventional without the cover crop, the low disturbance time with the cover crop, low disturbance time with the cover crop, rotary tillage, the canopy cover, which again is a very good indicator of yield, of final yield, because of the photosynthetic quality of that canopy cover and how that affects the tubers developing underneath. There were no significant differences, no matter what treatment you use. So this is very positive, that even if we've taken our foot off the gas, then canopy cover does not seem to be affected by that change in practice. So now let's look at some actual results, some actual numbers. And again, this is it's sort of simplified in a way. What we've done here is take the mean of 3 sites. The 4th site results weren't in, so we've only taken 3 sites. But what we've done is we've taken the mean of those 3 sites and compared the results relative to the conventional practice. So the conventional practice is always baselined at 100 units. So you'll notice that there are no units in this figure, in this table, and that's deliberate because we've standardized, if you like, the results so that the conventional practice without a cover crop has 100 units. And then we compare the other treatments below the conventional practice. So we compare these other treatments relative to the conventional practice. So you'll see at planting, the good news is that indeed tillage intensity, as we expected, the conventional was by far and away the most intense cultivation that we carried out, which is good news because that's what it was designed to do. Or certainly the low disturbance rotary tillage were not designed to be as intense as the conventional practice. So you can see there the differences in tillage intensity calculated through the STIR rating, which I mentioned earlier. You can also see, and this will be good news to our farmers and growers, the work rate increase, the ability to increase the work rate. Obviously, that is related to the fact that we're not going so deep and therefore we can carry out operations much faster. And that was certainly noticeable for those more, let's call them regenerative, or no, I can't call them regenerative yet, but I can call them less intense cultivations. So the growers were happy. We were getting through the fields much quicker rate than conventional. Similarly, and related to that, of course, is the fuel use. And this is really important from an economic point of view, but also from an environmental point of view, because if you're using less fuel, you're relying less on fossil fuels and the greenhouse gas emissions associated with the use of that fuel. So yes, there are cost savings, but also there are lower greenhouse gas emissions. And then that final column is not greenhouse gases associated with the fuel consumption. These are the greenhouse gas emissions associated with the tillage operation. So again, pro rata compared with the conventional, we were seeing much lower greenhouse gas emissions where we've reduced the intensity of that tillage. So again, that is a very good environmental message to take home. So at planting, this all looks rather good, and these are very positive impacts on reducing the intensity. And I have to emphasize, this is 1 year's data that I'm presenting, and I have to emphasize this is a mean of 3 sites. There was variability between the 3 sites, but I thought that would be death by PowerPoint if I show you, right, this is site 1 result, site 2 result, site 3 result, site 4 result. And frankly, lunchtime isn't that long. So this is why we've presented this at this sort of headline value, a presentation. Now, what about harvest? Because again, clearly our growers are particularly interested. Yes, 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 that's all very well in planting, but what about the harvest? Because at the end of the day, if my yields are down, if my marketable yields are down, I'm kind of not that interested, perhaps. No, maybe that's being a bit cruel to growers that they're only interested in harvest, but they're economic animals and that marketable yield is really important. So the data show, look at the yields, for example. So again, we've standardized all of these metrics so that the conventional practice is 100 units. So it is dimensionless, but purely so that we can make reasonable comparisons. You will see there was a yield loss from those less intensive cultivations, not massive. And again, we have done the stats on this to say whether that was significantly so, but I haven't presented the stats for the purpose of this lunchtime seminar. The dry matter content, which obviously is very important, that's total yield, that would be fresh yield coming off the field. Dry matter content, which is very important for producers and processors. you'll see that actually there was no difference in the dry matter content once those potatoes had gone into storage, that they were comparable, which is encouraging. Bruising incident, and remember I mentioned the difference between yield and marketable yield. Bruising incidents, for the low disturbance time, we got a slight increase in the amount of bruising that was taking place, possibly to do with the stone content not being taken out. Remember, there was no destoning as such, and the high stone content is inevitably going to lead to increased bruising associated with that. But whereas the rotary tillage, and I know somebody's going to ask me, why did the rotary tillage have less bruising incidents? I know the number is higher, but it's actually, no, the other way around, sorry. It had more bruising incidents. Why was that the case, whereas the low disturbance didn't? I can't tell you the answer to that without looking back into the results. So please don't ask me that question. And then other defects, but this was again of concern, that the other defects were both external defects, so on the skin of the potato, also internally, and greening effects. You'll see that again, the low intensity cultivation had higher defects. And again, I emphasize that this is just at the end of year one. It has amalgamated all of the results from the 3 sites, which had quite different conditions. So it's purely to give you a headline, and there is much more nuance when you look at individual sites and indeed year on year. But it gives you a flavour, hopefully, of the differences that we're picking up from those different cultivation treatments. And on the basis of those results, we can now see at what point in those cultivations we need to maybe take out a few more of the stones, maybe go a little bit deeper to try and avoid some of these defects that we saw in those less intensive cultivations. And so we're learning from one year to the next, and we're making modifications to the equipment, the kit that's being used. And again, you'll say, well, therefore you can't compare year 1 with year 2, year 3. And we don't really want to, because we want to compare between treatments at a given season. The other danger of comparing year 1, year 2, year 3 is that there are going to be weather differences. You know, year 1 might have been very dry, year 2 would be very wet, year 3 would be very hot. So we can't really compare over time, because those externalities will be different. What is really important is that for a given season, what is the difference between those treatments? And the grand scheme, as I said, this is a 4-year project. So the grand scheme is that all of the data that I've just scratched at the surface here on the agronomy, on the soil, on the stone content, on the harvesting, the grading, the end use of the crop, the management capacity, all of these factors that I've really just skimmed over, we're going to try and use to come up with a decision support framework, so that growers can say, okay, I've got this soil, my last crop was this, my follow-on crop will be this, I'm growing it for crisp production, I'm growing it for chip production, etc. We then will come up with guidance, and only guidance or advice, and it's not advice, it's just guidance as to what tillage strategy might suit that specific scenario. So that's the long-term plan of how we're going to bring in all of this information together in some sort of decision support framework. So this is my last slide. I'd like to acknowledge the funding that we're getting for this project. Very important, because frankly, it's taxpayers' money. I appreciate that. It is co-funded by Defra's Farming Innovation Programme. And as I say, it's delivered by Innovate UK. But I'd certainly like to thank all of the project partners. As I say, we are just a very small cog in this big project. I would like to thank all of the project partners that are listed there. And I'd especially like to thank my Cranfield colleagues who go out in all weathers, you know, come rain, shine, snow, hail. It's not glamorous doing all of that soil sampling, but we love it on a sunshiny day. So I'm happy to take any questions, and I hope that was of interest to you. Thank you very much.
Thank you, Jane. That was excellent. Thank you. I notice if anyone's got any questions, do you fancy just chucking them into the chat? I see Tim has put a carefully worded written statement regarding CTF, which I will come to in a moment. And I'm just going to cheat and ask my own question first while people are thinking. And it's a really quick one, Jane. Is do you think, given that you've very carefully caveated 1 year's results on one site with what you've shown us there, that customers' expectation of the quality of potatoes may be at odds with what we require out of the establishment and growing process? And I'm thinking specifically about the wonky potatoes I buy slightly cheaper from Aldi when I go shopping on a Saturday morning.
Yeah, I mean, I think some supermarkets are doing a very good job at trying to avoid this uniform standard size where everything looks beautiful and sort of very cosmetic and aesthetically pleasing on the shelves. I think supermarkets are doing a good job on that. And I think this, because we're doing a lot of work on the grading and the marketable quality of the spuds at the end of the process, I think that will answer some of those questions. I'm not really answering your question, am I? This project isn't looking specifically at that, if I'm honest with you, Andy, but I think the results will feed into that. Does it matter that you get wonky potatoes?
Certainly, if you look at your project partners, you've got potato producer stroke end user suppliers, haven't you, there with McCain's and Walker's and so on and so forth. So that they'll have a job of work to do to produce a lower carbon product, which is what they're looking to do, isn't it?
It is indeed. And I think if you just look at PepsiCo primarily interested in crisps, where marketable yield is critical. McCain's are looking at processed potatoes. So therefore, because most things get processed much more, so crisps, you notice much more the defects. With processed potatoes, it can all be processed. I'm not saying it's not important, it is important, but there are different processes that the potatoes go through as to how important that end quality is going to be. And that's why I'm delighted we've got PepsiCo, because they have their standards and McCain have their standards. I'm not saying one is better than the other, they're different, depending on the product they're producing.
I think probably given that the questions are filling up in the chat here, I'm going to paraphrase Tim's comments here, other than to say that, he's flagged up that, no mentions made of the role of soil compaction in potato production. And he just goes on to make the point that obviously combining operations may well increase the load of the machine system and thus the depth to which the compaction reaches. I think Tim's probably preaching to the converted with that one, where we kind of get that. But although no alternative mechanism is presently available to avoid this level of extensive compaction, I think maybe he's asking, if we went to, say, a reduced width gantry scheme like the current Nexat system, what do you reckon? Maybe you could give us some comments on moving to a wide span production system, which just took the machine off the bed, Jane.
Yep, absolutely. So we are measuring compaction in the soil health indicators, but I'll be honest with you, Tim, it is just in the rows where the potatoes are being grown. I believe that Harper are interested in following up from their excellent trials on compaction wheelings that I know Tim has been involved with. Then I think Harper are doing something on the compaction within the wheelings themselves. I'll be honest with you, the project is not, I know how important compaction is in potatoes, in the wheelings and so on, and because of the machinery. But we are not specifically looking at compaction in wheelings on this particular project. But I take on board what Tim is saying. And again, gantry system, that's really important, interesting, because GRIMME are looking at developing new kit using conventional tractors and conventional machinery, not gantry systems. That would be the next step forward. How their mechanization, their developments in mechanization could be better suited to a gantry system. And that would be the ideal, but I think we're taking little steps, step by step. And again, none of our growers use gantry systems. or wide spacings. I think we need to get the proof of concept with the growers that we're working with first, and then the next step would be to see the implications of that for control traffic farming and indeed gantry systems. So I'm afraid, I know Tim will be very disappointed, and I think he said he's disappointed, but that kind of, it should have been part of the project, but we had to define the scope to some degree. But that, as I say, the implications of this project for control traffic farming and for gantry systems will not be lost.
Yeah, it's still a signpost, isn't it, Jane?
Yeah.
In that regard.
Yeah.
I'm going to move on. William Wadilove had just asked, what was the cover crop, and was it cultivated in green or was it desiccated? And if it was desiccated, what was it desiccated with? So.
Very good. So the cover crop varied for the different sites. I don't have the species. It wasn't, and it was just a standard cover crop mix. So it had, I can't remember the species. I don't have the species.
Phacelia,
yeah, exactly. Phacelia, ryegrass,
fodder radish, forage radish, maybe
yeah,
something like that. Yeah.
So I don't have that information off the top of my head. I think it was primarily, it wasn't cultivated in green. No, it was, hang on a second. No, it is left. Is it left? Okay, I'm really sorry. I can't remember. The conventional, because it doesn't have a cover crop. Okay, I'm really sorry. I don't remember in all the sites whether it was desiccated by chemical or whether it was cultivated in. And I think that will depend on the primary cultivations that were used at each of the sites, as if primary cultivation was required involving inversion, then the cover crop will be cultivated in with those primary cultivations. Some of the other sites, we didn't need to carry out that primary cultivation, that inversion. Therefore, it was only secondary cultivations. And I can't remember off the top of my head, because I wasn't involved in that process, as to what happened to the cover crop. So apologies, I don't know.
Paula's just dived in there and said cultivated in. Paula thinks they were cultivated in, so full marks, Paula.
Love you, Paula. Thank you very much for let me off.
I don't know whether we can go back in the presentation, but Phil Metcalf's just asked if you can show the slide on harvest and particularly review the bruising explanation, or just give us a quick run through because from memory the bruising was broadly analogous across all four approaches, wasn't it?
Yeah, I made a mess of that slide. Thank you for pointing that out. Right, bear with me. I'm going to share it again. Okay. Yes. So this is the slide. And so the bruising. So let me repeat. Apologies, Phil. I made a mess of this slide. So my apologies. Again, I have to say I'm not a post-harvest technologist. I'm a soil scientist. So this isn't my area of the project. I am really sloping shoulders today, aren't I? I'm not taking responsibility for anything. So that's a bit rubbish. So sorry. But there are post-harvest colleagues who are really up to date with what bruising involves and why it's going. So in answer to your question, so the conventional, we gave a standard value of 100 units, dimensionless units. Where we had the low disturbance tine without the cover crop and with the cover crop, then the bruising incidence went down. So less bruising. But where we had the rotary tillage, the bruising incidence went up. And I think I said in my presentation, please don't ask me a question about that, because I don't know the answer. So sorry, Phil, but I think I did caveat that by saying, so basically the implication is that the low disturbance tine had less bruising, whether that was because of the stone content or lack of stone content for a particular site. I don't know. Remember, this is the average. This is the mean of 3 of the 4 sites. So within that, there will be variability between those 3 sites. And it might be that one site had very high bruising incidence and another site had very low bruising incidence, which doesn't make any sense to try and explain that. But then the average, which is what you see on your screen now, was the average of those 2. And overall, it looks like there was less bruising, but actually that might be a statistical quirk where you've got somewhere more, somewhere less.
Yeah, if
So,
you've got very different soil types, Jane, if you've got
absolutely,
a
yes.
sand versus a gravel, for instance.
Right. No, so we did select on the soil type thing, we did select the sites so that they would have reasonably similar soil types. So they're round about a sandy, loamy sand. And why did we do that? Because most potatoes will be grown on that soil texture. So the soil type kind of it's the stone content that was really different between the sites. And I think that will explain why on some of the very stony sites we probably had more bruising incidents, and the less stony sites we had less bruising, and that's why we get a mean in the middle. Again, it's a quirk of the stats, and it is also a limitation of having an average of all three sites when we know those sites are very different.
Yeah. Marion has a question here. Was the reduction in yield balanced by the reduction in fuel and equipment pass costs?
That's a horrible question. Thank you so much, Marion. So it's apples and pears, actually. That's the problem to compare that. We have partners on board that are trying to look at how we can standardize the units between yield and reduction. I suppose you're talking about the economics of it, the costs of it, and that is something that project partners are working on at the moment. I don't have the data but we do have Ceres Rural as consultants who are looking at the economics of the whole system. And that would answer Marion's question in terms of reduction in yield, and then you'd have to know about marketable yield. You need to know about the commodity price for that particular year, compare it with fuel costs for that year and equipment and so on. So that economic analysis is being done, but I haven't presented that today. The results aren't out for that. But thank you, Marion. Good question. Very good question. But standardizing those units is quite a challenge.
I'm going to keep moving on because I've got 3 or 4 more, and we've got 6 minutes, Jane. So we're going to go into speed questioning now. Martin Parsons said, any comments on how PotatoLITE applies to growing potatoes in peat in the lowland fens?
Excellent question. So again, we deliberately chose sites that had similar, not the same, but similar soil textures. We didn't look at peat because we thought that was quite a different, that's probably going to be quite a different animal altogether. I'm hoping, Martin, that PotatoLITE Plus might then apply some of the learnings from this project to look at growing potatoes in peat. And I know, again, that is an issue, not least because of greenhouse gas emissions. And I hope that some of the results, they won't be immediately transferable to peat soils, but certainly this business of reducing the stir, reducing the intensity of cultivations may well apply in peat soils. But that's something that would need to be tested with another experimental program, because theoretically that would be the case. But again, because the production systems are quite different, quite similar in some ways, quite different in other ways, I think we'd need a whole set of trials. And I'm sure GRIMME would probably design their equipment differently to cope with peats rather than these very stony soils. So, for example, you don't need destoners in the peat soils, and that is a critical part of the equipment that we're developing in PotatoLITE.
Just moving on to Sarah Grantham's question. Presuming the potato variety was the same on all sites? Question mark.
Yeah, no, they weren't, because we were following advice from the growers. So I understand where you're coming from, Sarah. From an experimental point of view, a scientific point of view, it should all be the same. But because they are geographically dispersed, those growers would grow different varieties, and therefore we went along with that. And again, I should say, I did make the point that I'm not interested in comparing year 1 with year 2, year 3, because those years are very different. Similarly, I'm not really comparing all 4 sites. I'm interested in the treatments at a site. I cannot expect that the grower in Leicestershire is going to have the same results as or the same variety as the grower in Yorkshire, or indeed in Shropshire. They will have different varieties. What I'm really interested in at a given site let's compare those 4 treatments for the given potato variety that they're growing at that site. So it would make a more elegant experimental design, yes, but what they grow in Shropshire, their varieties, they wouldn't be growing in Yorkshire or Leicestershire.
And the second part of that question was, would different varieties of potatoes be more suitable to different processes?
Oh,
i.e. the regen potato
oh,
variety, which is probably the potato version of the El Santa strawberry, I imagine, and
okay.
90% rubber.
Yeah, okay, very good. Again, brilliant question, Sarah. I think let's see what treatments we find are the most suitable in PotatoLITE, and then we could ask the question about what is the role of variety. We do have that information actually in PotatoLITE because we've got different varieties at the different sites. So we could do that analysis, but it's because I'm comparing between sites, which I don't really want to do because of the change in geography between those sites. We could probably say that Maris Piper, you know, is more effective. Oh, I don't know. It's a bit messy. It's not very sound scientifically. What we could do, though, is to, when we've chosen the treatment that is most promising, then look at how variety might be affected by that particular treatment. I think that's PotatoLITE ++. So that's the second follow-on project that I'd like to do.
Part trois, not part deux. Just going on, there's a couple of points of information and clarification in next comments, and I think Tim's just come back to say, you know, he fully understands the constraints under which you're working, and he said together with a colleague in Australia they undertook a feasibility study of a 6-metre gantry for potatoes and concluded it would work well and deliver centrally to a regenerative approach. So I think that's probably a point of information from Tim.
Good.
And it is 13:59, so I apologise you haven't quite picked up on some other people's comments. I think it's time to heartily thank Jane for her kindly giving us her time today to explain a bit of this and allow herself to be roughed up by some of the other soil compaction, potato and engineering specialists in the room. So you've done ever so well there, Jane. Thank you very much. From my point of view as chair, and again, you know, it's always a pleasure you know, being in the shadow of an actual expert. So I've enjoyed sitting, listening and scribbling a few notes as we've gone along as well. We have got, so thank you, Jane. And I will just say at this point that we have got the next lunchtime lecture, which is on the 8th of April from 1 till 2 on employment on the law. Join us for a power-packed lunchtime lecture with Paul Harris, Managing Director of Real Success Limited. Dive into recruitment and employment law essentials as Paul reveals insider tips to attract top talent and maintain a compliant, thriving workplace. Take a breath, that's a long sentence. Anyway, it's all there. It's on the website. I think you can click and register, and that will all be dealt with in due course. Once again, thank you so much, Jane. Much appreciated.